and now we want to talk about isomers. So with isomers, these are molecules that have the, and kind of relating this to the isotopes and ions. So iso means the same, and so in this case, the same. And mer kind of has to do with units or what it's made of. But in terms of isomers, you have molecules with the same molecular formula, so an identical molecular formula. So this means they have the same number of each of the different types of atoms. So like C6H12O6, there are 3 isomers that all have this, and this is glucose, and this is also the molecular formula for galactose, and this is also the formula for fructose. So these are all isomers. They all have this formula here, but they don't have the same arrangement of those atoms. So they have different structures. They have different arrangements of these molecules, or different arrangements and different bonding to make the molecule. So different structures, different, and when you change the shape, you change its function. So we've mentioned this again. They have different then characteristics. So they have different functions. So structural isomer, there's one type, and then there's a second type, which is called a stereoisomer. And a structural isomer has, this is just the typical, like these 3 molecules, glucose, galactose, and fructose would be structural isomers because they have the same number of atoms, but they just have different bonding relationships. So they have a different arrangement of those atoms. And they don't even have like the same functional groups a lot of times. So stereoisomers, they have identical bonding patterns, but they have their spatial positioning differs in the 2 isomers. So how they're arranged, so you have to remember that carbon has 4 bonds to it, and sometimes those carbons can flip and be on different sides of the atom, or different sides of the carbon. And so there are cis-tran isomers. These are 2 types of stereoisomers. And then there's enantiomers. So these would be mirror images. In fact, enantiomer means, enantiomo means opposite, not stereo. Okay, it means opposite. So they are mirror images of the, the molecules are mirror images of each other. And so we kind of talk about them like you have L isomers and you have D isomers, and L means like left-handed, and you have D isomers, which means right-handed, like dextrose. Like if you're ambidextrous, you can be either one. So dextrose D means right-handed. And so those are just opposite of each other. So look at your hands, like hold them up, and you put them, you look at your left hand and your right hand, looking at the palm side, and the thumbs face outward. And if you turn it over, the thumbs face inward. But those, if you put one on top of the other, they're going in opposite directions. So they are left and right-handed. This is what the enantiomers are like. So that is what most people think of when they think of a stereoisomer. But there is another kind, and this is what I really wanted to do this video for, was to talk about the cis-trans isomers. So this is the positioning around the double bond. So you have, like in a lot of molecules, you will have a carbon double bonded to a carbon. And so if those hydrogens are both on the same side, then you have some other parts of the molecule here and here. This is called the cis arrangement because they're on the same side of the carbons. But you can also have, and see, they're bonded to the same number of carbon. So this hydrogen is bonded to this carbon, and this kind of hydrogen is bonded to this carbon. But you could also have a situation where, again, you have this the rest of the molecule going either way. So you have 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds. So that's all that carbon can make. So there's nothing down here because we've filled up all of the bonds. But sometimes that hydrogen can be on opposite sides, and so that is what you see here. So this is when they're on opposite sides. Those are called trans. That's the trans relationship. So when they're on opposite sides, that's a trans arrangement. So that's opposite sides of the same double bond, the same carbon double bonded to each other. So that's a little bit about the difference between these. Technically, I guess they are sort of mirror images of each other too, if you want to look at it that way, but not quite. So let's look at some examples. So here you can see in figure 3.3, you have isopropyl and propyl alcohol, and so that, you know, we just moved where the hydroxyl group was. So we've moved it from the second carbon to the third carbon over here. And so that is just a structural isomer. So it's not a mirror image or anything. It's just a different arrangement. So just a typical isomer. But now here's your cis butane and here's your trans butane. So they have that double bond between them, and these two are on the same side. Their cis arrangement, and here's the trans arrangement of those hydrogens. And so this was cis butene, and this is not butane, butene, and this is trans butene. And so N enantiomers would be like this, where you have, it looks exactly like a mirror image of the other. So those are a couple different types of the structural isomers and a little bit about the functional groups. So hopefully that is going to help you. The rest of the videos are pretty much the same as what I would need you to know, but these are two things that weren't explicitly discussed in the videos for chapter 3, and so I wanted to make sure you got that.